Hi there and welcome to the channel, the Linear Algebra channel. My name is Ferguson Mangoma. In this video, I would like us to talk about matrices. Obviously, the first question would be, what is a matrix? Now, a matrix is a rectangular array of numbers. So let's write the definition down. A matrix is a rectangular array of numbers. On the right board here, I do have a couple of examples of matrices. As you can see, the numbers are arranged in rectangular form. Now, each one of these numbers in the matrix is called an element or an entry. So these numbers are either called an element or an entry. So matrix A has 4 elements, matrix B has 6 elements, matrix C and D have got 9 elements, and matrix E has got 6 elements. Now, what is the size of a matrix? First of all, let's look at how the numbers are arranged. They are arranged in rows and columns. So A has got 2 rows, the numbers in the horizontal line, and 2 columns, the ones arranged in a column. B has got 2 rows and 3 columns, 1, 2, 3. C and D have both got 3 rows and 3 columns, 1, 2, 3. And lastly, matrix E has got 1, 2, 3 rows and 1, 2 columns. So the size of a matrix is given by the number of rows and the number of columns. And it's written as M by N, the size of a matrix, where M is the number of rows and N is the number of columns. So, for A, number of rows M is 2, number of columns is 2. So A is a 2 by 2 matrix. So we can write it here, 2 by 2 matrix. What about matrix B? M is 1, 2, N is 1, 2, 3. So B is a 2 by 3 column matrix. Sorry. What about our matrix C and D? 3 rows, 3 columns. So C and D are both 3 by 3 matrices. And we can repeat that here, 3 by 3. What about matrix E? 1, 2, 3. So M is equal to 3, 1, 2, and N is equal to 2. So E is a 3 by 2 matrix. So those are the sizes of the matrices here. Now, let's also talk a little bit about types of matrices by looking at this bunch over there. Let's look at them very closely and see how we can further describe them apart from their sizes. Now, if you look at matrix A and matrix C and matrix D, they have got one thing in common. The number of rows is equal to the number of columns. For A, it's 2 by 2. For C and D, it's 3 by 3. Matrices such as these are called square matrices. So we can write number 1, A, C, D are square matrices. They are matrices when there are many. It's a matrix when it's one. Okay? Let's look a little further again. If you look at matrix C and D, every other element apart from elements in this diagonal here, which is called the main diagonal, let's circle it. The numbers here This is our main diagonal here. And again, this is our main diagonal here. So all the elements that are not in the main diagonal are equal to 0. The only elements which are not 0 are the elements in the main diagonal. 3, 6, 2 for C and 1, 1, 1 for D. Matrices like these are called diagonal matrices. So number 2, another description. So C and D are diagonal matrices. Sorry. Okay, let's look a little further down again. Let's look at matrix D. Yes, it's a diagonal matrix, but it's special because all the elements in the main diagonal are 1. Such a matrix is called an identity matrix. So matrix D, apart from being just a diagonal matrix, it's a special type of diagonal matrix called an identity matrix. So number 3, let me get my black. Number 3, matrix D is an identity matrix. And it is symbolized by capital letter I. It's an identity matrix. So those are the descriptions of our matrices. In our next video, we are going to deal with the subscript notation, how to describe particular elements in a matrix.